Okay, today we'll be learning about strings. Hey, Code Operative here, helping you reach further faster in the programming world. If this is our first time meeting, welcome to the channel. The Code Operative channel is for developers of any level. This is a resource that will help you be confident in your skills and solutions. If that sounds appealing to you, hit the subscribe button, the bell, and keep watching to build those programming muscles every day. So today we're going to talk about strings. What is a string? A string is an array of characters. So in Java, you would see something like you put the quotes and then you write "Hello World," end quotes, right? And that's what you know as string now. But what string actually is a wrapper around a character array, right? So you remember arrays. Imagine that you have a char array that is equal to H E L L O. Right? So now I'll just call this character array high. So high now looks like this. H E L O, and then each letter has single quotes around it to indicate that it is a character. Okay, so this is high. So as a string, it wraps this and makes it immutable. So what does immutable mean? Well, immutable means that it is that it cannot change. So we haven't talked about the final modifier, but the final keyword means it cannot change. So it basically makes a char final array and sticks it inside of this wrapper called a string. But what about when, you say hello plus world? This returns hello world, right? Well, that's because it's actually creating a new string. It's actually creating a new memory reference. So if we go back to our memory representation, right, this string is still here, right? This still says hello. But now, and then world is somewhere even farther away, but now this string, right, has been stuck right here. So now they've put hello and then space right. So it's duplicating that string. And the reason it does that, the reason it keeps that reference around is because whenever you use a string literal, whenever you do one of these, it's going into something called the string pool. So all these strings are just floating around in here. So anytime you make a reference to one of these strings, right? So you have A equals hello, and then B equals hello. This is going to return the same memory area because it checks the string pool and it says, hey, does this exist already? Let me just throw that memory area back to this. And the reason it can do that is because all of these strings are immutable. So even if someone tries to modify these strings in some way, they can't, right? They're immutable. So they know that they will never, ever change. No matter who they give this reference to, it will be the same. Or at least that's the assumption. So say you wanted to check to see if A was the same as B, which obviously it has the same internals. This is going to return true. But not because the internals are the same. It's going to return true because, this string in the string pool has a reference to 0x0f memory address, right? That's where it's referring to when it pulls this hello. And whenever you write hello, it returns this memory address. So the reason these are the same is because A and B actually have the same memory address. And that's what this equivalence operator is checking and saying, hey, is A equal to B? And what is the default implementation of that? Are the memory addresses the same? Whenever it's not just a base primitive like integers, characters, shorts, bytes, etc. But this is not what we want to do when we compare strings. You have to use the inbuilt string methods, right? So you would do A dot equals B. And that would actually compare the characters inside of the string. And what's more, this equals will check to see that the characters are the same case, because this is all based off of something called the ASCII table. Right? Alright. So I pulled the ASCII table up for us. So let me just write out the word that we're using again. Right? We're using capital H-E-L-L-O. Okay. So what does that actually mean? Well, we know it's an array. So the array stores the value of characters. So what is the value of H? Well, we look at the decimal value of H, which is 72. 72. 72. Right? So that's the decimal value of capital H. And then what's the decimal value of lowercase e? Well, that's 101. Lowercase l, that's 108. Another 108. And the lowercase value of o, so here's e, here's l, and here's o, 111. So you have your character array, it's storing these decimal values 72, 101, 108, 108, and 111. So assume you have a second string. Now B is lowercase h-e-l-l-o. Right? So the lowercase h is 104, 101, 108, 108, 111. If we say A equals B, where this is B and this is A, it's going to say, all right, let me check their lengths. They're the same. Cool. Is the first character the same? The first character here is 72. First character here is 104. Wait, those aren't the same. Are they equal? False. So now instead let's do another string method, which is equals ignore case B. And this will equivocate to true because we're saying specifically ignore case. So this is 72. Right? It's going to check, is this 104 or 72? No? What about the lowercase version of 72? What is that? Let me add 32 to this lowercase and check. 104 minus 32. Well, that equals 72. How did I get 32? Well, there's 26 characters in the alphabet, and starting here and ending here, right? We have an additional 6 characters between our two alphabets. So 26 plus 6 was 32. So there's a 32 character difference between the uppercase and the lowercase. So if we take 104 and we subtract 32, we get 72, which is the uppercase H. Is that the same? Yes. Okay. And then it just does direct comparisons across the board. Boom, it's true. So now you know that hello, the string, is actually a wrapper around this char final array. Right? So strings have another method called char at. So if you do char at, well, let's do position 3. So it's going to go 0, 1, 2, 3. Right. And then it's going to return you the character L. So this is no longer a string. So if I'm referring to a string, it's a dot char at. So you have the string, and then you use this dot notation to reference a method that is related to this string, which is char at. So it's saying find the char in this string at position 3, so it'll go into its little internal character array, and it'll go 0, 1, 2, 3. Okay, let me return this L. And it does as a character. So strings have this another cool little method called substring. So you have your string name and you're going to call dot substring. And then you pass your starting index. So my starting index is going to be 1. And then you pass your non-inclusive end index. I'm going to pass 3. So this will return a string EL. So this second parameter is non-inclusive. Go from 1 to 3, right? So it's going to go 1, 2, oh, now I'm at 3. Stop. So, non-inclusive. And string has some other methods for manipulating the shape of the character array. So, but it doesn't actually change the character array, right? It returns a new string. Just keep that in mind. So when you do a dot to uppercase, it's going to return a new string that is all uppercase. And it also has a to lowercase option, which, you guessed it, makes it all lowercase. There's some other few methods, like you can do a.trim, and that will remove any white space on the end. So say that a equals something like this, right, where there's a bunch of spaces before and after. Then a.trim will return without all that white space. Remember how I said the characters are stored as ASCII values? So when you do something like a.char@, and then position 2, okay, 0, 1, 2, that'll return L. You could do something like int my character equals a.char@2, and now my char is going to equal 108, right? 108. 108. So now my char is equal to 108. Well, by the same token, you should be able to say char third letter equal to my char. Unfortunately, Java doesn't work like that. You have to tell it specifically, hey, pretend this integer is actually a char. And then it should assign perfectly fine. So that's all I've got about strings. I hope that was helpful. Okay, now that you know about strings, what are you hoping to accomplish? Let me know in the comments below.